Welcome to PSY 3204, Psychological Statistics. This video is about understanding the numbers behind human behavior and how we interpret them. We are focusing on turning data into understanding. As W. Edwards Deming said, without data, you're just another person with an opinion. Life is full of patterns. Studying statistics helped me see that behind every struggle, there's a measurable cause and effect. The purpose of psychological statistics is to help psychologists analyze behavior scientifically. It builds a bridge between research and real-life decisions. Descriptive statistics involves the mean, median, mode, and standard deviation. It summarizes data to reveal trends. The average never told my full story, but patterns did. Here's a fun fact. Most people misunderstand averages. The average person doesn't exist, as means, medians, and modes tell very different stories. Inferential statistics involves drawing conclusions from samples and understanding probability and significance. In life, we make decisions from limited information. The brain is terrible at probability. Humans often see patterns where none exist, leading to fallacies like the gambler's or hot hand fallacy. Correlation does not equal causation. Correlation identifies relationships between behaviors. Connection doesn't always mean cause. Sometimes, people cross paths for growth, not permanence. Correlation often feels like causation. This is why even trained professionals can sometimes confuse the two. Hypothesis testing involves null and alternative hypotheses, using methods like t-tests, ANOVA, and chi-square. Like testing a new routine, you must experiment to see what truly works. A result can be statistically significant, meaning the p-value is less than 0.05, yet practically meaningless. Data ethics and integrity require honesty in reporting results and avoiding bias and manipulation. Integrity in numbers mirrors integrity in life. With enough variables, you can make almost anything look significant. We'll look at 3 examples of spurious correlations: ice cream and drowning, study time and test scores, and happiness and social media. Example 1. Ice cream and drowning. Adding variables like temperature and season can make the correlation between ice cream sales and drowning incidents appear statistically strong. The real cause is hot weather. Without theory, statistics can create a false narrative. The lesson is that correlation plus extra variables does not equal causation. Example 2. Study time and test scores, a p-hacking classic. By adding variables like sleep, caffeine, and music type, you can run multiple regressions until one combination produces a significant result, p less than 0.05. This is misleading because the result is often random noise that would disappear upon replication. Multiple testing inflates false positives. Example 3. Happiness in social media, a modern big data trap. By adding many variables, a significant result, p less than 0.05, might be found, leading to headlines like "Social media causes depression." It's misleading because the effects are often tiny, the direction is unclear, and context is ignored. Remember, statistical significance is not the same as practical significance. The remaining slides are blank, serving as a reminder that the video is coming to a close and to reflect on the concepts discussed. These blank slides allow for a brief pause to process the key takeaways from the video. We have covered descriptive and inferential statistics, causation versus correlation, and the ethics of data reporting. Remember to critically evaluate any data presented, especially when large numbers of variables are involved. The difference between statistical and practical significance is a crucial concept in psychological statistics. Avoid the temptation to find patterns where only random noise exists. Integrity in reporting results is foundational to credible psychological research. We hope this video provided a clear understanding of the numbers behind human behavior. Thank you for watching this introductory video on psychological statistics. Further exploration of these topics will deepen your understanding of statistical methods in psychology. We encourage you to revisit the examples of spurious correlation to solidify your learning. This concludes the video for PSY 3204, Psychological Statistics. Slot machine, psychological statistics, and the lottery. Why do people play when the odds are so bad? From a statistical standpoint, the lottery is irrational. From a psychological standpoint, it makes perfect sense. Brain key psychological and statistical concepts at work 1. Probability neglect. People focus on the possibility of winning, not the probability. Downward trend. Example, odds of winning Powerball, approximately 1 in 292 million. Odds of being struck by lightning, approximately 1 in 15,000, lifetime. Yet the brain treats both as possible. Availability heuristic. If you see winners on the news, your brain overestimates how common winning is. Newspaper weird news effect. Media coverage spikes lottery ticket sales even though odds never change. Gambler's fallacy. If it hasn't hit in a while, it's due. Crossmark. Statistically false. Each draw is independent. Game die numbers do not remember past losses. The lottery isn't just a game of numbers. It's a lesson in how the human mind bends statistics to protect hope. Thanks for watching. If you enjoyed this breakdown of psychological statistics, be sure to like, comment, share, and subscribe. Signing off, this is Cognify 365.